Prior to the invention of telescopes in 1572, a Danish nobleman and astronomer, Tycho Brahe, discovered a new star in the constellation Cassiopeia. He used his superior vision to compare this star with fixed background stars while Earth changed position during its orbit around the Sun. His observations determined that the new star was present in the distant fixed stars. This was the first of two discoveries he made, which discredited the knowledge about the cosmos that prevailed during his time period. Scientists of his age were sure that the distant stars, being part of the heavenlies, could not change. And yet, here was a change, a new star. When an observation contradicts the prevailing knowledge or theory, it is an anomaly that weakens the prevailing theory. It often signals that a theory is not correct. Although change is needed, however, a scientific revolution requires new ideas and an intellectual battle. Galileo Galilei designed a telescope that improved magnification 30 times. In January 1610, he was able to identify 4 moons around Jupiter. This contradicted the Earth-centered model that most scientists believed at the time, and supported the Sun-centered model, which was advocated by a few mavericks. Better observing power helped to verify the better model. In 1919, astronomer Edwin Hubble took a staff position with the Mount Wilson Observatory near Pasadena, California. There he was able to use the new 2.5-meter Hooker telescope, which was then the world's largest. Using the telescope, he made discoveries that fundamentally changed the scientific view of the universe. Many of the remote smudges that were thought to be gaseous clouds called nebulae were actually galaxies. Not only did he discover galaxies outside of ours, he was able to make measurements that paved the way to discover the expansion of the universe. Throughout time, better, clear observations that are enabled by new technology often show up the deficits of existing theories and drive the need for new explanations. In recent times, observing capability has greatly improved due to the Hubble Space Telescope, space probes. The Kepler Space Observatory, the Spitzer Infrared Space Telescope, the NuSTAR X-ray Telescope, the Chandra X-ray Observatory, ALMA, 66 radio antennas spread across 10 miles, and other radio telescopes. Is the current orthodox model of star formation confirmed? No. Significant anomalies have been discovered. Planets outside our solar system, called exoplanets, include planets that are too close to their respective suns to have formed according to standard theory. Friction and gravity would have caused the planet-forming material to fall into the star rather than form a planet. Also, scientists have observed stars that are too close to the black hole at the center of our galaxy to have formed the way that current standard theory predicts. The recent observations of young star object CX-330 show an X-ray source with no infrared presence change to the infrared presence of a star within 3 years, a much shorter time period than standard theory predicts. This Kickstarter project supports the launch of a new groundbreaking theory via a book entitled Mass Vortex Theory, Development of a Solar System from Atoms to Star. The explanations in mass vortex theory match up with our best astronomical observations.